So now that we know how to find a turning point, there is another method that I'll show you here. We can actually graph these. So we want to find three things every time. We want to find our y-intercept, which is very straightforward. It's just x equals 0. So we just sub that in. Y equals 0 squared minus 16. So y equals negative 16. Done. Y-intercept, 1 down. I tend to write it as an actual point to remind myself of what I'm plotting. Okay, next one, x-intercepts. All right, so as I was saying, we generally do our factorizing here. So I can see that that is a difference of 2 squares, so it factorizes as negative 4 and positive 4. So I know x equals negative 4 or positive 4. So those are my x-intercepts. Nice, straightforward, just using the algebra we've been learning. So then the last one is your turning point. So there's 2 ways we can do it. Well, there's 3, but 2 we're going to look at. One is using our axes of symmetry. So we know that if we add our intercepts together and divide by 2, that is going to give us the x value for our turning point. And then we would sub that back into the original equation. But we don't really need to do that because when x equals 0, hey, that's our y-intercept. So we've already done that. Beautiful. So that's one method. The other method is using negative b on 2a. So that's the first bit of the quadratic formula. So we've used the bit under the square root, that's our discriminant. Now we're going to use the starting bit of the quadratic formula to find the x point on our turning point. So we would sub our values in. So you got to remember b is the bit that's attached to the x. I don't have a b in this one, so I'm going to sub in 0. Then 2a, so that equals 0 as well. Perfect. So we can use either method to find that x value, and then you would sub it into the original. So I know my turning point is also my y-intercept. Don't forget to put the little y and the little x, or I will dock you marks. So now I can plot it. Drawing them is the hard bit. They always come out a bit skew-iffy, but just try your best. And make sure to label all your points. If you find information and don't put it on your graph, that is just silly. Cool, and there's my happy little quadratic. Alright, another one. This one actually has a b term, so we can give it a go. So our y-intercept is when x equals 0. So that's actually really easy to see, because if x squared is 0 and 6x is 0, it's just 5. So y equals 5, so I don't really even need to do any maths for that one. First bit done. Now my x-intercepts is when y equals 0. So this one actually involves a little bit of factorizing, but we can do that easily. Multiply together to get positive 5, add together to get positive 6. Easy, 5 and 1. So x equals negative 5 or negative 1. So those are my intercepts. Cool. Then the last bit, turning point. Well, we've got the intercepts, so we may as well use the axes of symmetry. So we add our intercepts together, which equals negative 3. Cool, that's not one of the points we've already found, so we know we're going to have to find something else. So then we sub x equals negative 3 back into the original. So we get y equals negative 3 squared plus 6 negative 3 plus 5. 9 minus 18 plus 5 is 4. Negative 4. So there's my turning point. That's all you got to do. Not too bad. And then we graph. So I generally try to plot your points in. I'd use a pencil, because once you do that, you can just play connect the dots. Negative 1, negative 5, and my turning point is negative 3, negative 4. See, as I said, I can now erase that little dot, just put him in the right spot. And turning point. Alright, and then don't forget to label all your points. That is important. And 5. Done. Alright, go into chapter 3F, page 109, questions 3, B, D, F, H, and question 4. Make sure you're always labeling those 3 important points.